Hey guys, today we are going to talk more about logs, all right? And we're going to talk about the relationship between exponential functions and logarithmic functions. And we talked before that when we graphed them that they were inverses of each other, right? And what we're going to do is we're going to talk how we can convert from exponential to logs and logs to exponentials. And then we're going to talk about how to evaluate logs, okay? So the first thing is how we can change. If you look here, we have 2 to the cubed equals 8. That's an exponential. That's an exponential form. All right. This is an exponential. All right. What if I want to convert this to a log? All right. So that's what the E arrow L means. We're going to convert an exponential form to a logarithmic form. Okay. Now, to do that, all right, this converts to log base 2 of 8 equals 3. All right. Now, where did I get that from? Okay, real simple. This right here is the base of your exponential, right? Which means it's the base of my log. All right. Then this number here, whatever it equals, goes after the log, and this is what it's equal to. So the way you read this is log base 2 of 8 equals 3. All right. Log base 2 of 8 equals 3. It's the same thing as 2 cubed equals 8. All right. So for this one, 5 to the 4th equals 625. I want to convert that to the logarithmic form. This is log base 5. So it's a subscript down there. Log base 5 of this number, 625, equals the exponent, 4. So log base 5 of 625 is 4. All right. For 6 to the 0 equals 1, this is log base 6 of 1 equals 0. All right. Log base 6 of 1 equals 0. All right. This would be log base 4 of 1/16. Just put in parentheses just to make it easier to tell that the 16th on the bottom with a 4 equals -2. Right. So log the base, this is the base of this equals that. All right. All right. So for 5, log base 10 of 100 equals 2. Now, the way you can write this, remember, base 10 is the same thing if you don't have to write that, all right? It's log of 100. So remember, if you don't see a base, we assume it's 10, all right? These mean the same thing, equals 2, right? These are the same thing. All right? If you have E, well, log base E of 7.388 equals 2. Well, log base E, the other way of writing that, we don't write really log base E. That's what we call the natural log. So that's a natural log of, what is that? 7.388 equals 2. All right. So that's how you convert from exponential to log. All right. Now to do it the other way. All right. So if I want to convert this to an exponential, all right, it's almost going to be something called like left, right, left. All right, so it's going to be, remember, this base, if you go back up here, all right, this base turned into the base of the exponential. What was on the right is the exponent equals back over here to left. So it's going to be left, right, left. All right, so left 5 to the right, -2 equals 1 over 25, which is true, right? 5 over to negative seconds, really 1 over 5 squared, which is 1/25. Left, right, left. All right, so left, 7 to the right, 1 equals back to the left. That's supposed to be equals 7. 7 to the first equals 7. Right here, there is no base. So what is the base? Oh, it's 10. 10 to the right, which is 3, equals back to the left, 1,000. All right. Natural log. What's the base of a natural log? E. E to the third equals, this isn't correct. I think I wrote something down wrong here. Well, based off of this, this is not correct because I don't think 2.718 cubed. No, actually, it might be right. 2.079. Now, because 3 cubed is what, 27? 2 cubes 8. Yes, that could be right. All right, so when there's no base here, it's e. E to the right side of the cube equals left. Left, right, left. Right, left, right, left. All right, that's how you convert from logs to exponentials. All right, so now what we're going to do is we are going to now be able to evaluate a log. All right, so for example, if I want to know what log base 2 of 8 is equal to, all right, log base 2 of 8. So basically I'm trying to figure out, well, what does that equal? All right, well, let's convert this to an exponential. All right, so left, right, left. I'm looking for 2 to what power, basically x, equals 8. Well, 2 to what power equals 8? Well, the answer is 3. So log base 2 of 8 is 3. All right, for 2, all right, there's no thing here, so let's convert this to an exponential. What am I trying to figure out what this equals? So it's 10, because there's no base here, to what power equals 1 over 1,000. Now, what does this mean if you have 1 over 1,000 or 1 over something? That means what about your exponent? Well, it means that it has to be negative. All right, so 10 to what power gives you 1,000? Well, it's 3, but I can't do 10 cubed is not going to be 1 over 1,000. It's 10 to the negative third is going to be 1 over 1,000, right? 10 to the negative third is the same thing as 1 over 10 cubed, which is the same thing as 1 over 1,000. So if you see a fraction like that, it's going to end, the exponent is going to end up being negative, all right? All right, so we are just looking, we rewrite this as exponential and then evaluate from there. So there is no base with a natural log, it's e. So it's e to what power gives me e to the 9th. All right, what makes that true? What's x? The answer is obviously 9. All right, so we're just looking, this to what power gives me this. All right, so this is 5 to what power gives me 5? Well, easy enough, 1. All right, 5 to the first is 5. All right, no base, what does that mean? That means 10, right? 10 to what power equals 1? Right? 10 to what power equals 1? Well, what's the only way, any number to what power gives you 1? Answer is 0. All right, so log doesn't matter what this base was. If you have log some base of 1, the answer is always 0, right? If I had 5 to the x equals 1, what's the answer? 0. Doesn't make a difference. All right, the answer would always be 0. All right, this one's a little bit trickier, so let's go through it. Let's at least set it up as an exponential, right? So it's 4 to what power equals 32. All right, and we'll get more to ones like this when we do exponential equations and log equations, but there is no whole number, right? 4 squared is 16, 4 cubed is 64. But how can I rewrite 4? Can I rewrite that as 2 squared to the x? And how can I rewrite 32? 2 to the 5th, right? So this is basically 2 to the 2x equals 2 to the 5th. Well, what is it? Just if the bases are the same, set the exponents equal. 2x is equal to 5. X equals 5 halves. All right. On this homework, you probably won't see anything like that, but this is a good preview of what we're going to be doing later on. All right. And then I think I got one more down here. Yep. All right. So convert this to an exponential. 25 to what power equals 5. Now, what you probably notice is that this one's bigger than that. What does that mean? Well, that means that this exponent probably is going to be a fraction, because what's the relationship between 25 and 5? It's 5 squared is 25, right? Or the square root of 25 is 5. How do I represent the square root in an exponent? Well, the square root can be rewritten as 1/2. So it's 1/2 is the answer. because 25 to the 1/2 is the same thing as the square root of 25, which is 5. So if you see where this is bigger than that, you're going to have to do a square root possibly, all right, or a cube root. For instance, if I had log base 8 of 2, it would be 8 to what power gives me 2? Well, what's the relationship between 2 and 8? 2 cubed is 8, which means the cube root of 8 is 2. So this would be 8 to the 1/3 is equal to 2. So the answer would be 1/3. All right, so that's something else to look forward to. All right, so your assignment today is just going to be a worksheet. You're only going to do the first 10. All right, and we're going to be working through logs for the next couple weeks, and you guys are just going to have one more assessment on logs to finish up the year. All right, I hope you guys are all doing well. If you have any questions, please let me know.